The next question is question number 4, which says that 3.162 gram of calcium carbonate CaCO3 is reacted with 20 centimeter cube of 4.0 mole per dm cube HCl hydrochloric acid. Write an equation for the reaction including all the state samples. Okay. Equation will be CaCO3, which is solid, plus HCl, which is aqueous, will react to form CaCl2 plus CO2 plus H2O. This will be the equation. The CO2 form will be a gas, the H2O form will be liquid, and the CaCl2 form will be aqueous. If I balance it, I will get 2 here, and the equation is balanced. Next question. Deduce which reactant is limiting reagent using section 147 of the data booklet. Okay. Now, in order to find out the limiting reagent, I should have the moles of both CaCO3 and HCl. So I will find out the moles of first CaCO3. Number of moles of CaCO3, that is N, will be equals to given mass 3.162 grams, 3.162 upon the molar mass of CaCO3 is 100.09, which is 100.1 I can say, and the answer, if I solve it, it comes out to be 0.0316 mole. That is the mole of CaCO3. Now, in order to find the moles of HCl, I have the volume, I have the concentration. Moles of HCl will be equals to C into V, that is concentration into volume. And what's the concentration? Concentration given to us is 4 mole per dm cube. 4.00 into volume is 20 divided by 1000, and that comes out to be 0.0800 mole. This is for HCl. Now, in order to find out the LR, I have to divide CaCO3 moles with 1 and HCl with 2, because the ratio is 1:2. Therefore, 0.0316 upon 1 and 0.0800 upon 2. It is 0.0316 and 0.0400. Since these are the less moles, hence CaCO3 is my LR, limiting reagent. Okay, this is a B part of this question. That is question 4A, part 2. Now part 3. Calculate the volume in dm cube at STP for the gas produced, section 2 of the data booklet. Okay. Section 2 tells about that the molar volume is 22.7 dm cube at STP. And if I see the equations, my LR is CaCO3, and 1 mole of LR gives me 1 mole of CO2. That is, by this equation, I can say CaCO3, 1 mole gives us 1 mole of CO2. And what the moles of CaCO3 I have? 0.0316. 0.0316 will give you 0.0316 mole of CO2. I have a volume of CO2 at STP equals to moles into 22.7, and that comes out to be 0.0316 into 22.7 dm cube, 22.7 dm cube, 0.0316 into 22.7 dm cube, and the answer comes out to be 0.717 dm cube, 717 dm cube. That should be the answer. The B part is the rate of this reaction can be experimentally determined by measuring the volume of gas produced as time progress. That is the volume of the CO2 gas. Sketch another curve for the reaction taking place with the acid at higher temperature and all other conditions are unchanged. Okay. So what I'm doing, I'm increasing temperature of the acid, and as I know the temperature increases, the kinetic energy of the gas molecule will increase, or the particles will increase. Hence, rate will increase. Therefore, more volume of this gas will be produced in less time. But since CaCO3 is LR, therefore the final volume will be same. CaCO3 is LR, hence the final volume will be same. That is, the curve will end at same point, but the gradient of the curve should be higher. Therefore, I can start this curve from here, go up, and will end here only. The final volume will be same, therefore it will end here only. So if you want to draw it, you can draw it this way. The final volume, the original will be same, and it will go up, gradient will be high and will end at this point. Both the curve will have same ending because the final volume will be same, but the gradient is high since the rate of reaction will be high. Okay, that should be the answer for this question. Outline why the reaction rate would be lower if the ethanoic acid were instead of hydrochloric acid. If I use ethanoic acid is a weak acid. Since CH3COH is a weak acid, it partially dissociates. Its dissociation will be less or partially dissociates, whereas HCl completely dissociates. CaCO3 is a weak acid, it partially dissociates as compared to HCl, which is a strong acid and completely dissociates. It's a weak acid, that should be my point, and partially dissociates. HCl is a strong acid and completely dissociates. That should be the keywords of this question, although it is of 1 mark only. Next, C part is calcium carbonate and calcium chloride are ionic compounds. Annotate the bond-Haber cycle for calcium chloride by filling the names of processes and the formula of species, including state symbol in the boxes. Okay. Now, if I see CaCl2 formation, enthalpy of formation is on the first step. This is CaCl2 enthalpy of formation. This is delta HF. Species present. And if I go up, species present to form Ca and Cl, enthalpy of atomization. So what are the species which are forming? It should be calcium solid plus Cl2 gas. That should be the species present here, because they will undergo atomization and form calcium gaseous and chlorine atoms gaseous. Now this calcium is converting into Ca2 plus, that is it losing 2 electron. Therefore it should be the first and second ionization energy of calcium. That should be the process here. Now after converting to ions, the calcium is converted into Ca2 plus ions. Now the chlorine will accept electron converted into Cl minus ions. Therefore the species present will be Ca2 plus, which is coming from the top, plus twice of Cl minus. This should be the species gaseous and gaseous. Okay. And then lattice enthalpy, CaCl2. Yes, all complete. So we should write all these things, and then I will get, I think it's of 3 marks for these 3 things. First and second ionization energy of calcium, and then Ca solid and calcium chlorine gas, and Ca2 plus ion gaseous plus Cl minus ion gaseous. Okay. Outline why the lattice enthalpy of calcium chloride is lower than lattice enthalpy of magnesium chloride. Okay. Calcium chloride has lower enthalpy. You know that lattice energy is inversely proportional to size and directly proportional to charge of ions. Since both of them, Ca2 plus and Mg2 plus, have 2 charges, therefore there will be the difference in size which will control this lattice enthalpy. So what I can write here is lattice enthalpy is inversely proportional to size of ions. Since Ca2 plus is large in size than Mg2 plus. Ca2 plus is large in size than Mg2 plus. Hence, CaCl2 will have lower lattice enthalpy as compared to MgCl2. That should be the answer. MgCl2. That should be the answer, because lattice enthalpy is inversely proportional to size of ions, and since the charge is same, therefore there will be no effect on the charge. Lattice enthalpy is directly proportional to charge. There is no effect of charge because same charge. What is affecting? Only size is affecting. Therefore that should be the answer. Question 5 says 40 centimeter cube of 1 mole per dm cube sodium hydroxide NaOH gradually added to 15 centimeter cube of 1.0 mole per dm cube ethanoic acid. Okay. So what I'm adding? I am adding a strong base to a weak acid. Strong base is added to a weak acid. Hence, what I have to do, I have to sketch a pH curve for this titration. Okay. Since the acid is weak, its pH should start, or the curve should start around 2 to 4. The pH curve should start around 2 to 4. So I can start around 2, or between 2 and 3, I can start around this point. Okay. And since the base is strong, Therefore, it should be end around 1 mole per dm cube base, then it should be end around 12 to 13, flattened around 12 to 13. Okay, it should flatten around 12, 13. Why? Because the pH is coming out to be 1 mole per dm cube should be around 13. So it should flatten around 13. Okay, these are the 2 pointers. And what volume I am adding? I am adding 40 centimeter cube drop by drop in 15 centimeter cube of ethanoic acid. Now, since both are monoacidic bases, it is a NaOH contains 1 mole of OH ions and CH3COH also contains 1 mole of H plus ions. That is the monobasic acid, and it is a monoacidic base. It means 1 mole will react with 1 mole. Therefore, the number of moles will be same. And since the concentration is same, since they have same concentration, both have 1 mole per dm cube, 1 mole per dm cube. Therefore, 15 centimeter cube of ethanoic acid requires 15 centimeter cube of sodium hydroxide. Hence, my volume should be around 15. That is, the equivalence point should come around 15. These are the 2 pointers I should note. If I draw a curve, the third point is, since the acid is weak and the base is strong, therefore the equivalence point should be greater than 7. Equivalence point pH should be greater than 7. These are the pointers I should note. If I plot a curve, it should be a sigmoid curve. It should be a non-symmetrical sigmoid curve. It should not be a symmetrical curve. It should be a non-symmetrical. I am starting from about this point, going up, and from around 15, the pH, there will be a shoot up in the pH, and it will go, since the base is strong, it will go around 11, 12, and then end around 13, 14. That should be my curve. It should end around 13, and then it should go. This should be my curve. This should be my curve if I plot this diagram. Okay. Now, if I find out the equivalence point, it is half of this point, which is greater than 7, hence correct. It's starting from 2, hence correct. It is ending around 14, correct. And I think all the pointers has been covered in this curve, and this is your equivalence point range. Equivalence point range, and this is your equivalence point. Okay, and the volume will be 15. Therefore, all these pointers, I think they should be the markers for this curve. Next, NaOH and CH3COH are mixed to make a buffer solution. Describe how the solution can produce the most effective buffer. In order to make a buffer, we should find out which type of buffer it is. It is a buffer of weak acid, and when I mix a strong base to it, it will form a salt of the weak acid with strong base. Okay. In order to make an acidic buffer, this is an acidic buffer. They will form an acidic buffer. This will be an acidic buffer. What I should do, I should add, or it can be done by, it can be formed by adding drop by drop NaOH solution in the acetic acid solution, CH3COH solution, until half of this acid is neutralized. Until half of acid is neutralized. What I mean by this, since they have same concentration, therefore I should add about 7.5, half of 15 ml is about 7.5 ml. About 7.5 ml of NaOH should be added. Thus, what will happen? Thus, salt of weak acid, that is CH3COH, with NaOH will be formed, and half of acid CH3COH remains unreacted. CH3COH remains unreacted. This unreacted acid and its salt will have a ratio of about 1:1. Therefore, it will convert into a buffer. This will result in formation of a buffer. What I have done, I added drop by drop NaOH in this acetate solution until half of the acid is neutralized, and half of acid means about 7.5 ml of this NaOH should be added. Why? Because the 15 ml acid was 15 ml, hence half of that is 7.5 I will add, and it means half of it is neutralized. Thus, the salt of the acetic acid will be formed with NaOH, that is CH3CONa will be formed. It is CH3COH is to CS3CONA, and the ratio between these two should be 1:1. That will result in formation of buffer. Write equation to show. Next is write equations to show the action of the buffer solution when small amount of strong acid or strong base is added to this. When I am adding strong acid, strong base to this buffer, I am adding strong acid, small amount. The acid will have H plus ions, and these H plus ions will combine with the acetate ions of the buffer, CS3CO minus ions of the buffer, to form CS3COH, which is already the part of buffer and no change in pH. Okay. Whereas if I add a strong base, the strong base will have OH ions, and these OH ions will combine with H plus ions of the buffer. They will combine with H plus ions of the buffer and they convert into water. And they will form water. Hence the added OH ions are neutralized. These are added ones. These are from buffer. Here these are added and these are from buffer. Both ions get neutralized. Thus there will be no change in pH. Okay. For more detailed help in IB and IGCSE examination, you can visit to this website www.ibvijyan.com, and this website has many useful features for IB and IGCSE, like we have test papers, we have topic wise question banks, we have topic wise practice papers, and a comprehensive course which contains all complete study material which is required for the IB preparation, and that contains the practice papers, the test papers, the question banks, the subjective question banks, the question bank for paper 1B. And one unique feature of this is, if you attempt these papers and practice papers, the MCQ will be automatically checked and the answers will be received as soon as you submit the papers. Whereas the subjective question banks or question papers, if you write and upload on the website, then these will be checked by the experts and the result will be sent to you within 48 hours. And I hope this will be helpful for your preparations. I recommend you to please go and visit this website, and if you think it is useful, you can buy it and purchase it. Thank you very much once again. Thank you.